As you probably know, the freezing point of a solution is lower than the freezing point of the pure compound. We have a freezing point depression, and this is often used in organic chemistry to tell whether your compound is pure or not. Let's take a look at what happens to the freezing point of a solution as we change the composition of the solution. As an example, let's look at an aqueous sodium chloride solution. By measuring the freezing point of various solutions of sodium chloride, we can graph the freezing point of those solutions as a function of the composition, in this case as a function of the weight percent of sodium chloride in the solution. When we have pure water, no sodium chloride in the solution, our water freezes at 0 degrees Celsius, as we know. When we increase the amount of sodium chloride in solution, the freezing point of that solution is depressed. In other words, the solution freezes at lower and lower temperatures. When the solution is fairly dilute, when we have low concentrations of sodium chloride in the solution, if we examine the composition of the solid that is formed when the solution freezes, we'll find that it is pure ice. There is no salt in that solid. It is completely water. And so in this composition range, the saltwater solution, as it freezes pure water and leaves the salt in solution. However, if we go to low enough temperatures, the entire solution will freeze and we'll have a mixture of ice and salt in the solid phase. When we get to higher compositions, more sodium chloride in our solution, the opposite will begin to occur. The salt will begin to crystallize out of the solution. We often use this phenomena to our advantage in order to recrystallize a substance and form the pure substance from a saturated solution of the substance. So, for instance, if I dissolve enough salt into my water so that I have a fairly high concentration at a high temperature, and I cool that solution, eventually the salt will begin to crystallize out of the solution, and I can vacuum filter those salt crystals and have pure sodium chloride crystallized out of my solution. If my solution is not saturated enough or does not have enough salt in it, if I try to do the same thing, I cool it down and I end up with solid water rather than crystals of salt. The temperature and composition at which the solid and the solution have the same composition, in other words, the solution crystallizes completely and forms a mixture of solids, is called the eutectic point.